All right, this is the kind of problem that often trips people up on exams, so let's go through it a little carefully. Here they tell us that there's a constant force exerted continuously on a block that's initially at rest, and they tell us that from 0 to 50 centimeters, it has a change in kinetic energy called delta K1, and then from 50 to 100, they call the change in kinetic energy there delta K2. The question here they're asking us is, how does delta K1 compare to delta K2, and why? Now, when you see a problem like this, you might be tempted to immediately look at this equation, 1/2 m delta v squared, but this would actually take you down the wrong path. We don't know anything about velocity, we don't know anything about the mass of the block, and it wouldn't be a really beneficial approach, and we also don't actually know the value of the force to calculate velocity. Just no information in this equation is something we have. But instead, the approach you'd want to take is the work approach. And the way you'd reaffirm that you should take the work approach is because they use phrases like constant force and exerted continuously. Generally, they reserve phrases like that for problems related to work. So what you'd want to do now is look at how delta Ke is equal to F delta x, this being the equation for work. And the delta x, right, is the same for both of the movements, right? It's both 50 centimeters traveled between point 1 and 2 and then point 2 and 3. Now, for the force exerted, it's also constant between point 1 and 2 and point 2 and 3. Therefore, the delta Ke must also be the same. A and B are the only ones where it is equal between delta K1 and delta K2, and since the explanation we just talked about includes work, B is a correct reflection of what we just discussed, making it the right answer.